Dependency injection from your humans. As mentioned, I did do this talk over at PHP World. Unfortunately, a little short on prep time, so apologies for reading from the slides a bit. If you would like to follow along with me in reading the slides, then that link will get you there, and there are various portions of the slides that are linked themselves for additional resources and that sort of thing. So it's useful enough to follow along. I'm Ian Littman, and let's, I guess, get started. If this one. Where is my... What? Okay. Actually, Logan, so I'm not fighting with this machine throughout this presentation. Do you mind if I swap over to your machine, log in, and do the presentation from there?
Yeah, no problem.
Okay. Hi there, I'm Ian Littman, and we're going to be going through some stuff about dependency injection, a little bit about solid design principles, a little bit about dependency inversion, a little bit about dependency injection containers, which are not the same as the dependency inversion principle, and in general, a whole bunch of opinions on how to build your applications in a way that won't make you tear your hair out 6 months from now when you have to refactor things to based on one of those dependencies. You can follow along with the slides with the link on the screen. There are a few links within the slides, so that's why I mentioned that you might want to do that. So the inspiration for this talk was a few years back when Jeff Caruth gave a very similar talk on Nomad PHP. So anything good about this talk can be attributed to him. Any bad opinions can be attributed back to me. So I'm going to cover a lot of ground tonight, technical difficulties notwithstanding. Talking about types of dependencies and also types of ways of injecting them or not into your application or into a given class or object that requires those dependencies. We're also going to go through dependency injection containers, a few examples of them, what they do, how to use them properly, and how they sometimes don't get used properly, and kind of the principles of why you should and or should not do some particular process or in terms of injecting those dependencies. So the kind of big assumption here, and I figure when at the point that you're building non-trivial software, you're going to have to change the software that you built unless it's throwaway code at some later point, at which point you'll find out that highly coupled code is bad. Specifically, a highly coupled code where the implementation details of the thing that you're working on depends on the implementation details of basically everything else in your application, or most of it. You're going to wind up with an unmaintainable mess that any time that you're attempting to add a new feature or fix a bug, you have to change things about 15 different places because you end up with a bit of a domino effect. That said, you have to have some sort of coupling in your code to actually produce a useful result, whether that is pulling information out of a database or outputting something to the response on an HTTP request. Either way, if you have side effect free programming, then you also don't get anything useful done. So we have to figure out how to balance these kind of two extremes of completely decoupled code that doesn't actually do anything and highly coupled code that is really difficult to maintain or reason about and potentially buggy because you're pulling in your entire application with some of its weird behaviors to do a single thing. So the decoupled code is easier to reason about. It's easier to maintain because you only have to keep a few things in your mind at any given point in time when you're working on a piece of code. Rather than saying, okay, I need to think in the entire paradigm of my entire application and all of its little gotchas in order to work on a single piece of code. You can say, oh, well, I'm working on this piece of code. It requires these 4 or 5 other pieces of the application, or maybe these 3 or 2 other pieces of the application, and that's all I have to keep in my mind as I'm doing dev. So I say, okay, we're going to talk about dependency injection. We're going to talk about dependency injection containers. We're going to be talking about dependency inversion principle. What is exactly a dependency? Well, a dependency is anything that your concern, whether that's an instance of a class or a service or even a function call, requires to get its job done. And this, in our particular case, while dependencies could be something as big as the operating system that you're running on, or packages in your package manager, or even, say, composer dependencies in certain cases, we're talking about something at a very close-in level, at the class level, where you're just dealing with something that's in that particular code file. Say, okay, I need X, Y, and Z classes or objects to get my job done. Working with operating system level packages and that sort of thing, yes, that's a whole other dependency management ball of wax. And some of these principles still do apply, but we're talking at the software and at the class level. So we have a few kind of common dependency types here. One would be your data stores, databases, your caches like Redis or Memcached, your external APIs or maybe internal APIs if you have gone completely in the microservices direction. File storage is another dependency, whether that is local file storage or if you don't want your application to evaporate when a hard drive fails, then you probably have something patched over to an object store like S3 or Rackspace Cloud Files or Backblaze B2 because you don't want to throw money at Amazon. Logging is another dependency of an application. Yeah, you could throw error log in there everywhere, but at that point you're interacting with the global state of your application, and it's a little bit harder to control where those errors are being logged, and that's why you see things like monologue saying, hey, I'll sit in between. If I need to log to error log, I'll still do it, but you have more control when you're using monologue rather than something like an error underscore log call. And likewise, if you need to send an email or need to send a text message or need to send a push notification, that is another dependency, even if all that dependency does is throw the message on a queue and have a worker pick it up later, which, oh, by the way, that queue is still a dependency. The worker is pulling from somewhere, a database, hopefully not a database, maybe a key value store like Redis, or maybe an API of its own, another dependency. So those are some of the more well-known dependencies where you can say, oh, well, that's relatively obvious that I depend on that particular piece of functionality in order to get my job done. Well, you have a few more dependencies in here. For example, the current web request, your get, post, server, files, variable, superglobals, your environment, including maybe some of your secrets that you use to contact APIs. The current time is a dependency. I may or may not have learned this the hard way when I did not test for a certain case, and favor delivery was closed for service when it should have been open on the Sunday morning. Learned again the hard way to inject the current time into something that depends on it, rather than saying, oh, well, a new date time and it is whatever it is. Likewise, static method calls, Laravel facades that actually proxy to dynamic things under the hood aside, static method calls are effectively global function calls and should be treated as dependencies. The idea here is if you have an external dependency from your code to the outside world, then you need to be able to very quickly see what that dependency is, potentially isolate it, and potentially change what that dependency does elsewhere without affecting your underlying code. So we have this class here. We have a few dependencies. Let's see here. We got, well, here's an obvious one. It's constructor injected. So we see we have a new MySQL order repository with no parameters. We're not sure how we're getting the database there. It's pulling that out of thin air, maybe requiring a random file or something like that. We're not exactly sure how the MySQL order repository works, but we don't really care. It's constructor injected. We're fine there. All right, we have this global keyword because global's the new hotness. Global logger, and we use the logger later on. We say, okay, well, we're processing an order. The completed at timestamp is right now, so we're fine there. We go ahead and use the global logger to log a thing rather than using error underscore log. So we've got a little bit of encapsulation going there, but as we're going to discuss, not nearly enough. We are using that order repository that we constructor injected earlier. And then we're calling a global mailer function to actually send a notification. So I've gone ahead and highlighted these dependencies here. So we've got the obvious one in the constructor. We have the global call there. We have this new date time of figuring out what the current time is, and we have this static method mailer call. Okay, realistically, we're not going to see a global keyword in relatively new code, so this is probably what that's going to look like. You're still kind of pulling things out of thin air in your constructor here. So the reason that this relatively coupled code where we're pulling dependencies out from somewhere in the rest of the application is not ideal is it's a little bit harder or a little bit less satisfying to answer some of these questions of, well, what does the order processor depend on? I don't know, look at the entirety of the class and see what it calls. Or if I want to mock out the mailer, how do I do that? Well, you hope that mailer : send, or whatever the function was called, has some, I don't know, pretending variable or something like that where you can go in and say, actually don't send the email yet because I don't actually want to send out to my entire list because all I'm doing is testing, and also sending out an email via SMTP is kind of slow. And, well, if I want to see, okay, well, if that is the way that mailer is called elsewhere, then figuring out where mailer : send is used, maybe you can do a grep across the entire code base. Maybe your IDE has something built in saying, hey, look for anything with this method name, oh, and look for anything in this public method name, oh, and look for anything with this public static method name, and just loop through the entirety of mailer's public static methods and find out where it's used. But it's not exactly the easiest thing to do if, for example, you say, oh, well, instead of sending emails on orders, we're going to change the implementation of the mailer, or maybe we're going to change the interface of the mailer such that it conditionally sends an email or a text message or a push or some other sort of notification. Either way, some of these questions are harder to answer when you don't have a system that is built with decoupling in mind and built with the dependencies being explicit and relatively isolated. So dependency injection is, well, it's taking the external dependencies of your class or application in general and saying, we're going to push them into the class rather than to have the class ask for them at random points in time. So by the time that the class is instantiated, or by the time the class needs a dependency, it's already there for it. Now, key thing here is the dependency inversion principle is not, it's somewhat related to dependency injection, but they're not the same thing. We'll get to that a little bit later. So there are three types of dependency injection that we're going to talk about. We have constructor injection, setter injection, there's some property injection that you can do in there as well, and method injection at the function call site. Each of them have benefits and detriments, as we'll see momentarily. So constructor injection is, well, you push your whatever dependency it is into your double underscore construct method, and you can type in there and make sure that somebody is actually giving you the dependency type that you expect as soon as the class is created in the first place. So you're not passing in, say, a Redis class when what you're actually looking for is the PDO. So that's one thing. On the one hand, it's relatively simple. It means that your class has everything it needs as soon as it is a valid object. Catch with that is you might end up with a whole bunch of dependencies sitting in your constructor, and your constructor has 10 parameters and it's kind of unwieldy, and maybe some of those parameters actually take a little bit of time to instantiate themselves. So there are some there are some downsides to constructor injection, but personally, that would be the first choice for saying, okay, here's how I push my dependencies into my given object. And this is what I'm talking about when I say you may have a whole bunch of dependencies in your object, and then your constructor gets ugly. This, I renamed maybe one or two of the classes here, but this is actually pulled from code that I wrote last year, or maybe year before that. On the one hand, it's ugly. On the other hand, it's probably good that it's ugly, because at that point you can see that your class is doing too much, and you should probably sit back down and start splitting concerns out to where your class does less and has less for you to think about. Right now you have 10 or so things that you need to keep in your mind in terms of, oh, well, I'm working on this class, but here are these 10 other dependencies that I can use to do whatever I need to do. It means that you're putting additional cognitive load on yourself to just work on a single class. So you don't want to say, oh, well, we have 10 parameters. What we can do is throw that into an options parameter on the constructor, and we're good. But that kind of defeats the purpose of being able to very quickly see what your dependencies are in the class that you're creating. And you also lose type checking built into the PHP language by saying, oh, well, I'll have an options array, and it will have a bag of things in there, and I'm not sure what the things are, and I can no longer use type declarations to check it. So realistically, unless you actually have optional random parameters, like your JSON decoding something or what have you, at which point you're dealing with kind of parsing configuration, you don't want to use an options array to hide what is in effect a class doing too much and having a large constructor. So setter injection. This is useful for potentially optional dependencies where you may not need them at the very beginning of your class instantiation, but you might need them later. Or you might need to change the dependency during runtime. With setter injection, you can do that. With constructor injection, for all intents and purposes, the dependency underlying that constructor parameter, you're not going to swap it out. With setter injection, you can do that. With setter injection, you could theoretically make things immutable and say, oh, well, I've already got this dependency in there. Don't let it do another one, but you have some more flexibility there. Additionally, setters can be used in traits to take some behavior and say, oh, well, we have this dependency requirement. We have these methods that this dependency exposes. Let's throw that into every single class. So that there's some use to setter injection in particular. But another kind of riff on that setter injection side of things is property injection, where you just directly set a public property on a class to whatever the dependency is. And then you wonder why you set your database property to something that really shouldn't be there, because PHP does not have property type checking built in. Hack does. We're not writing hack. And as a result, property injection is a bit, yes, setter injection takes more code, but in terms of general safety, you're probably going to want to use setter injection rather than property injection. So either way, you have a little bit more control over the life cycle of a given dependency. For example, if the dependency takes maybe 150 milliseconds to instantiate, then you can say, actually, we'll just delegate that to the setter and set it when we need it, and don't when we don't. The con of that is that if you're relying on that dependency to be there when the object is created, obviously you're not going to have that guarantee. because the dependency isn't in the constructor. And as a result, you have to add a bit more code in terms of checking to see whether the dependency exists, and then you can call a method on the dependency. Otherwise, you call a method that doesn't exist because the object is null, and then you get a PHP error, and then nobody's happy. So to this effect, any time that, say, you have a setter injected logger, you say, okay, I'll go ahead and log to that. Well, you don't want to necessarily do this logger log because this logger may be null, and then you get, again, a call on null. So you say, okay, well, I check to see if the logger exists, and then I call the method, and then we're good. Or, okay, realistically, we have a check on our setter injector saying set logger of log interface, so we really don't need those instance of checks. We can just check to see whether the dependency is there. That's fine. You're still having to check for the existence of that dependency. The alternative is that we go ahead and construct, inject that dependency and say, hey, I need a logger no matter what. So that way I don't have to do these existence checks all over my code. And then if you want a null logger, then have that be a specific null logger object. The null logger object doesn't log. But from the code's perspective, the code doesn't have to worry about whether there's a logger in there or not, or what the logger does. It's an implementation detail. You can say, I want to log a thing, and if there's nothing that wants to do anything with that logging message, then that's fine. It satisfies the interface of throw a log into the void, or throw a log onto Logstash or Fluent or what have you. But at that point, you're extracting the implementation details, and you don't have to worry about those implementation details anymore. That's why, for example, you have, in the case of monologue, you have an explicit null logger that you can pass in there and say, hey, I want this object to be valid. I want this to be constructor injected, but I don't want it to log anywhere. So, as mentioned earlier, you can build functionality into a trait that has, say, a setter injected method, maybe a getter in there, a property to hold the setter injected object. For example, a loggable trait. Set logger, you have your logger property, and then maybe a proxy method that says this logger log a thing. And then you can use that trait elsewhere in your code, and you're not having to copy and paste boilerplate code for using that logger elsewhere. That's at least a somewhat valid way of doing things. One note there is that traits cannot conform to interfaces. You say implements an interface on a trait, and then PHP says you can't do that. But it is a valid way of mixing in functionality that requires dependencies into your code. Just realize that at that point you're relying on your dependency injection container to say, oh, there's a trait there, I'll go ahead and setter inject to make sure that my object overall is valid. Or maybe in your setter injection trait you say, make sure that this logger exists before doing anything useful to it. Or make sure that this property exists before doing anything useful. So you're pulling all your null checks for that property into that class. So parameter injection, as mentioned prior, you've got, in this case, you're talking actually about function calls. You're getting into the realm of functional programming here. This, if this looks kind of sort of familiar, it is the request response middleware method that you end up with on, say, Slim 3. You have all the dependencies of that current request injected right as parameters into the function call. And maybe your class has some additional dependencies on its own that stick around request to request. But the request details effectively flow through your application rather than being assumed to be static dependencies. So there are some use cases for saying, oh, well, your request flows through the application rather than sitting there as a global dependency. And that is the use case for which parameter injection, which is basically parameters to a function call, are useful. The catch with that, of course, is you have to keep track of the parameters to inject in the first place. So this is really most useful on dealing with a middleware system or something that flows a piece of data through a system rather than, in general, having static dependencies. So these various ways of dependency injection, you can use constructor and setter and parameter injection in a single project. Perfectly legitimate. Again, they each have their various pros and cons. You don't have to shoehorn yourself into a single way of injecting dependencies across an entire project. That would more or less be counterproductive. So the dependency inversion principle, as distinct from dependency injection, but somewhat related, is that when you're type hinting all your dependencies to say, oh, I need a database, I need a MySQL database here, I need some specific implementation of another thing over here. Actually, what you need is something that quacks like your database interface. It takes the same arguments on the same methods and returns the same response back, or something that at least looks like the same response and behaves in the way that you expect that response to behave. The key here is you want to implement functionality, and particularly when declaring dependencies, based on what you expect the dependencies to require as parameters and give back to you as results, conforming to an interface, rather than saying, I must have this exact class because I know that exact class does the thing that I want it to do. In effect, you want to have, for example, if you're trying to process orders and you have a data store backing that, you want a repository that conforms to an order repository interface rather than necessarily a specific implementation of an order repository. At that point, the order repository under the hood could be reading things from a file. It could be extracting things from a database. It could be caching things with Redis before extracting things from a database. Those are all perfectly valid. Your consumer code doesn't, and maybe shouldn't, care about what is going on behind the scenes. But the way that you would need to do that is declaring interfaces on your dependencies and saying, construct this with an order repository interface, rather than tying it to a specific implementation. So in this particular case, we've got some sort of text message gateway that we're using to send out notifications for password reset. Oh, wait, let's not do that because somebody could port your SIM away. But for the purposes of argument, let's say that we're sending, hey, you won this raffle notifications out because that one I actually do use an interface for that little text message dependency. In this case, we've got a Nexmo provider, we've got Twilio. They both do the same thing. They both send SMSs. The underlying implementation is a little bit difficult, or a little bit different, where the Twilio side of things is a little bit longer URL, and the next most side of things is shorter URL, different parameters, and that sort of thing. But we don't care as the consuming application because we wrote wrapper classes, and those classes conform to the interface, and at that point, all my calling class needs to know is, hey, where do I send text messages to? Oh, it's a dependency that sends text messages. Let's go ahead and do that. So the one key thing here is you don't want to have implementations leaking through to the abstractions. You don't want to have a, let's say that we have an older model Ford Explorer that requires you to turn a key to start the vehicle, whereas the Tesla Model 3, you get in the car with your phone synced to Bluetooth and it's on. At that point, if we were implementing the Tesla Model 3 class and the Ford Explorer class, and instead of pressing the accelerator, which we assume that in both of these cases, pressing the accelerator would actually cause the car to speed up. If we're talking about a start method that's not pictured here, that start method, if we're conforming to an interface, in the Tesla side of things, it is check if the phone is nearby with Bluetooth. If not, then throw an exception. Otherwise, no op. Whereas the Ford Explorer is turn the key and watch your vehicle roar to life. So similarly, let's take an actual kind of more software-y example here. And in each of these cases, no matter what the backing store is for this repository, the way that you interact with it, the parameters that it has, and the results that it returns are the same. And that can even be the case if you build your interfaces right. You could even have an asynchronous result that maybe the result isn't there yet, maybe the result isn't there for another second, but it effectively behaves like you returned a result directly from a database that had to be materialized before you returned it. If you build your interfaces correctly, then you have a lot more power to even get a bit better performance out of your application, because realistically all you need is a class that has some of these methods rather than the actual materialized object. And that's, if you look at like the Doctrine ORM, it has all these proxy classes that conform to an interface of usually the parent class, but doesn't necessarily have all the information in there yet. It'll pull info in the background if it needs to. So going back to our original class, let's start refactoring this. So in this case, we got our logger get instance. We got a few other dependencies in here that are kind of all over the place. So first off, let's take the easy ones. They're already in the constructor. Let's pull those out into constructor parameters and say, well, I need a logger. Okay, it's obvious I need a logger. Let's say that I need a logger to construct this object. Likewise, I need an order repo, so I'm going to pull that into the constructor parameters as well. The next thing we do is we realize that we have a dependency on the current time, so we'll pull that into the constructor as well. Again, you may think I'm going overboard here on, oh, well, what could possibly go wrong if it's the current time? Again, I've been bitten by that before. It's a lot easier to test things when you can set the object state up to be exactly where you expect it to be and then work from there. You can pretend that it is February 29th at 11:59 p.m. UTC 2016, or you can pretend that it is the second 1:30 a.m. when daylight savings time is falling back. So dependency injection containers, now that we have these dependencies constructor injected, we need something to push those dependencies into the object. That is where dependency injection containers come in. Or you could call them just instantiation engines. Their purpose is to, when I say I need an object of this class, their job is to go back and say, okay, this object needs these parameters, all right, get those parameters. Oh, some of these parameters need their own dependencies. Okay, go get those, and eventually you get a fully formed object back with all the dependencies that you wired in set up. And you have containers that are specific to a given framework. For example, Laravel's IOC container, Symfony's crazy, significantly more amazing these days than it used to be dependency injection container. Send Service Manager, you can pull it out into its own thing, but realistically you're probably going to be using that in either Zen Framework or Expressive. And then you have kind of these third-party dependency injection containers that sit on their own, can be added into a framework or into no framework if you're working on older code. For example, lead container or a DI or Pimple. And of course, in the case of Pimple, that's actually the container that Slim Framework ships with, but it's very much its own thing. So we'll take a look at Pimple and we'll look at lead container. So as mentioned, the point of a dependency injection container is to instantiate objects. You can, because at the end of the day you still need to get an object out of the dependency injection container, you can abuse dependency injection containers and use them as service locators, saying, oh, I'm going to pull a parameter out of the sky and then use it, and we'll see what that looks like and kind of why you don't want to do that later. So there are a few other places where the new keyword for instantiating objects may be used. If you're having factory classes or value objects that really, if you have say a money object of $100 US, then you already have the information that you need to construct the object. A $100 bill over here is the same as a $100 bill over here. You don't necessarily need to force every single new keyword to be used within your dependency injection container. So it's a bit of an important distinction that if you're doing applications right, you still may have new keywords other than in your dependency injection and service layer. So back when Twitter had only 140 characters, you had Twitty, the guy responsible for Symfony, Fabien Potencier, built this little dependency injection container where you use the property getter and your magic getter and setter methods to throw stuff into a container. The one key thing here is that when you are setting a dependency, you're setting it with a closure, a function that takes a parameter, namely the container itself, because the container will inject itself into that function. And then when that dependency is needed, the function is executed and the response stored back into the container. And the function is executed and then you get your dependency back. You actually, in this particular case, you don't store the fully formed dependency back into the container. There's not enough room in a tweet to have that caching functionality. So to use Twitty, you've got something that needs a logger here. And then you have your logger. Say, all right, I need a container. I set the logger into that container and say, hey, I have a logger and here's where it is. And then the next thing I do is, okay, I have a class that needs a logger. Let's go ahead and add that to the container as well and say, okay, when you are asked to instantiate this logger, call back to the container, pull the logger out, and then throw that into the instance of this other class that needs a logger. At which point, now you can use the magic getter method on the container to pull out your fully formed class that includes a logger. So there's been back and forth over the years of, okay, let's have this sort of ability codified into an interface. Not much of an interface, just something that you can say, that you can type in against, that you can say this implements a really quick container interface. And then if you're doing fancy caching things under the hood or YAML-based configuration or whatever, the application doesn't care. All it needs to know is, hey, can I find out whether a service exists with a given identifier? And can you please give me that service? So hence PSR 11. And I took the liberty of, now that we have 280 character tweets, building in PSR 11 into the original Twitty service container. So added a couple methods and the implements tag, and ended up with something that still fit in a tweet, just a longer tweet. So dependencies, let's go completely overboard here and take everybody's favorite coding exercise and say, okay, instead of saying maybe fizz or buzz, let's have some other string there maybe. So in this case, we'll just use default implementations, set print out fizz and print out buzz. And we're constructor injecting here, saying, okay, set fizz to the constructor injected fizz, set buzz to the constructor injected buzz. For all we know, fizz and buzz could have internal counters and be returning something different each time. And then we have our invoke method there, and again, this is everybody's favorite / most annoying coding exercise, so I'll leave that for y'all to look at later. So now we go ahead and build the container. We inject our dependencies, say, hey, set fizz to this, set buzz to this. Tell it, all right, when we have a FizzBuzz instance, it needs these two dependencies, so pull them back out of the container and instantiate the class and return it. And now we'll go ahead and use our fancy new FizzBuzzer and run it over that loop. If I copy and paste the code, which I won't because I guarantee you this machine does not have PHP running on it, then we would get a nice 1 through 15, 1, 2, fizz, 3, 4, buzz, etc. And then all the way up to FizzBuzz. So I mentioned how you can use a dependency injection container for service location. Well, the reason that you don't want to do that is we end up in the same sort of predicament that we did before, where we throw the container into the class and say, we need a container, we need something that has, get and has. Hey, we're even type hinting it against the container interop interface. We have a get, we have a has, we pull out, we see if the thing has all the dependencies we need or something that is named all the dependencies we need anyway. We get them out, we set them as our properties. Hey, constructor injection, right? Well, now you cannot tell by the signature of the constructor injection, or of the constructor, what dependencies you need. All you know is it needs the container that was used when this person built this class and ran it successfully once, if they ran it successfully. And now you know nothing about what exactly is supposed to be in the container. And as a result, you have to bake in your verification of dependencies elsewhere. So this is one less than ideal way of handling it. And this is the other less than ideal way of handling it, where you're like, oh, well, I already have the container here. I might need a dependency elsewhere. So let's just save that container as a property on my object and then reach into it anywhere in my code when I need a dependency. It's the kind of logical outcome of injecting a service container into your class in the first place, and you end up with code where randomly throughout it, it's pulling new dependencies out of the container. And again, you end up with a case where 2,000 lines later, you don't know what's going on in your class. So let's see how we're doing on time. I'll speed this up. So Pimple is now a PSR 11 compliant. It has the get and has methods container. It same thing with Twitty. You inject or you set, hey, this class at this identifier maps to this closure, and then when the closure executes, it returns an object, and then the object gets saved out into Pimple internal storage. And objects by default, services that are dependencies like that, are only instantiated once. It caches them for the rest of the request or the run of the command line utility or what have you. You can override that behavior, but that's your default. So by override that behavior, you can either tell it, hey, this is the factory, keep on giving me new instances of a given class each time I request them. Or if you want to save an actual closure, an actual callable, well, just a closure, into your Pimple storage to pull that back out and use it elsewhere, then use the protect method and say, hey, save this in, but I'm not trying to get you to execute the function and then give me out the result. I just want you to give me back the function if I ever ask for it. So, again, this is the default container for Slim 3. So you can use Slim 3 as kind of a service-located, you can use Pimple with Slim 3 as kind of a service-located micro framework if you want, which is what we're not doing here quite yet because we're just newing up a database with some not so secret parameters in there if I didn't have that comment in there. So let's take the PDO out and pull that into its own dependency on Pimple. So we've got that, but we're still, at this point, we're now using Pimple as a service container or service locator, saying, hey, I need the database because I need it to build my other repo and then use it from there on out. Let's pull things one layer further, pull that repo back out into the container. So, progress. But realistically, what we probably want to get to is actually using an action class rather than a callable to dispatch our route. At that point, the action class has a constructor, so we have somewhere that we can say, hey, go ahead and hand our repository into the constructor for this. So we do that, have our parameter injected request and response called there. And then set things up in the container to say, hey, we have this dependency here, we have this class, it needs this one thing. Can you go ahead and, when we ask for it, build it? And at that point, when we map the route, the dependency, if you map a route to a name of a dependency that is already known by Pimple, then it'll build out that dependency and then call double underscore invoke on it. If you have a colon thrown in there as well after the name of the dependency, then it'll take the dependency, instantiate it, and then call that method on it. So you can either use that as a controller or just as one action per class. Either way, at this point, we have a fully dependency injected little micro app. And if we need to test the action, then we can do that entirely outside of the realm of Slim. So League's container, it's a bit more complex. It has some different defaults. For the sake of time, I'm going to kind of gloss over this one, but League, one of its defaults, as I recall, is it'll give you different instances of each class if you configure it by default rather than giving you the same one each time. But you can tell it, hey, set this as a shared dependency, and it'll keep giving you the same one time after time. So, and it is a lot more string heavy, where you specify names of classes rather than just throwing closures all over the place. As I recall, that allows you to do some optimizations, including auto wiring of the container, where it looks at your constructor for your class and says, oh, well, I see that you're requiring an instance of this other concrete class over here, or this interface that you bound within your League container configuration to another class. I'll go ahead and inject that automatically because you did not configure that explicitly. There is a performance penalty for that because in order to do that, the League container package has to use reflection, which is the way that any auto wiring container has to go to the PHP reflection API and pull stuff out that way to figure out which parameters have which types. So it is slower, and that's why it's not on by default in League container. You can basically set it up as a fallback. But you see that pattern in other DI container implementations where you'll use auto wiring, you'll use reflection for getting things up quickly and out the door. But at that point, when you actually do, say, an app build command of some sort, then it will go through and figure out all of that reflection up front, cache the results, and at that point, things get a lot quicker. As I recall, Symfony 4's container does that kind of auto-wired by default, and then it'll cache things to where subsequent runs on each request are fast. Also, League's container supports setter injection, whereas it's hard, if not impossible, to do on Pimple. So, in this anyway, you can look up inflectors and how they work within League container. I've got that linked in the title of that slide. So that is the mile a minute run through of what dependency injection is, types of dependency injection, kind of when and when not to use each one, what dependency injection containers are, what the anti-patterns are of service location, and again, you do not need a dependency injection container to do dependency injection. It just makes it a bit easier, and the frameworks come with one. So with that, I realize I covered a whole lot of material in not a whole lot of time, so any questions?
Yeah, just at a very basic level, if you inject in the constructor, then it's available to everything in that class. If you inject in the setter getter method, it's just for that particular method function.
So setter injection, you still set it at some point before when you use the injected variable. So you might, for example, the pattern that I've seen and used is you take a you take a class, you say, okay, anything with this interface, tell your dependency injection container to set or inject it with this method in this class. So for example, this logger right here, this inflector says, anything with the logger interface, go ahead, or a set logger method, go ahead and set that. And now that's still happening on construction or very close to it. But at that point, the setter injection is merely not a guarantee that the object has a given class as soon as it's, or a given dependency as soon as it's constructed, but it probably has it at that point, and you have a little bit more control over the life cycle. But you're still, the setter injected in that point is still not used directly when it's setter injected. If you're using a dependency right when it passes a parameter to a function, that's parameter injection, and that's more kind of middleware style sort of thing. So you end up with something like, you constructor inject with a few parameters that you absolutely need, you setter inject with your logger, maybe you go on and do something else, and then you call a function that requires the logger later. Does that make sense?
We'll ask, after Ash, some more questions at George's.
Okay. I'm sorry for being less than clear on that one.
Yeah, no, that's mine.
So if you pass it, if you dependency inject in the constructor, you still have, you need to use at the top of the class, right? Like use this class or
so the use keyword there is only needed to shorten the, if you're type hinting all your parameters in the constructor, the use keyword, all that does is it means that you're having to type less characters in the constructor parameter list type hints. You do not, if I wanted to go all long form on everything, then I would not need the use keywords at the top of the class at all.
you just, like from the global namespace, just pass everything in?
Yeah, so you would end up with my constructor having a whole bunch of really long class names in the arguments because I want to type hint things. And then later in that class, I'm just accessing each dependency directly, and the runtime doesn't care whether I use the long name of the class or the short name of the class, or didn't actually type hint my parameters at all. Although if I didn't type hint my parameters at all, then I couldn't auto-wire.
Are you talking about traits or namespaces?
It's just namespaces. Namespace question. So theoretically,
Mm-hmm.
if you run across some code that has like you're injecting an array of crap,
Mm-hmm.
and they're using short names, then you could look at the use. Like how do you
So if you're saying a constructor has an options array or a dependencies array,
right?
That array, you cannot rely on the array indexes even to determine what types the properties are. You have to basically call get underscore class on each thing that you're passing in.
Okay.
The use keyword at the top of your class doesn't really save you from that.
It wouldn't type check the junk inside of the array.
No. And if you have a convention around, for example, the names of your dependencies in, say, your container, the convention that I've started using is the tag of the dependency or the ID of the dependency in the container is the fully qualified either class name or interface name, except in cases where I need two of the exact same type of class, but they're actually, database 1 and database 2. Then that may help if you ever have to introspect the container,
Like
or
if you have like a read database and a write database.
yeah. Although at that point, you could, in theory, take an adapter layer, wrap that database, and basically have 2 layers of constructors in a single dependency. And at that point, you actually have a distinct interface for 1, a distinct interface for 2, and then you solve your problem that way. But the way I've generally done it is, if you have 2 of a given exact same class of a dependency, then just call them something else, and diverge from that convention elsewhere that you have elsewhere. But that is merely a convention. That doesn't save you from. I have a parameter bag of stuff in my constructor, and I don't know what it is.
I just want to throw this out there. One thing that is highly complementary to dependency injection pattern is lightweight constructors, where the only thing the constructor does is set a property on the object. It doesn't reach out to a database. It doesn't reach out to a file. And that way you can do the entire container, and everything can be injected and set up all at once. And it doesn't have like the 150 milliseconds
Yep.
you mentioned earlier with something. So you can get away from setter injections by doing lightweight constructors. And there are cases where, like my job has a QIP database. Their API immediately calls out to load a 50 megabyte file. We're like, that's not okay. So we just drafted in our own implementation that waits until we actually use it before call.
Thank you for making that remark. That is an extremely good point. And as I've gone to basically dependency injecting all the things, you're right. The only thing that I do in my constructors at this point is set a bunch of properties. It makes the recursive build this, build this, build this, build this, and constructor inject all the things that actually work. And similarly, if you're using the PDO, yes, it will reach out and connect to the database by default if you start it. There is, I still use Aura SQL, which is a basically drop-in replacement for your PDO with some additional convenience functions, and that will lazy load your database connection. So you can use that as a parameter in your constructors and all that sort of thing all the way down the line without worrying that if your database takes a little while to connect, then you're holding up the works everywhere else. Anything else?
All right. Well, if you think of something, you can ask me at tacos.
Yep.